Bismillahirrahmanirrahim. How are you, students? Today we will start a new chapter, unit number 16, lecture number 25, subject physics, class 10th. The name of chapter is Basic Electronics. Basic Electronics. Now, first we will study that what is electronics. General definition of electronics is the science dealing with the development and application of devices and system involving the flow of electrons in a vacuum, in gaseous media, and in semiconductor. So, in which we that branch, according to this definition, that branch of physics in which we study the study of flow of electron in an electrical circuits, particularly made from a semiconductor. The flow of electron in vacuum, in gases, all these are studied in electronics. Modern definition: the science dealing with the development and application of devices and system involving the flow of electrons in semiconductors. Now it is restricted definition. Electronics is the branch of physics that deals with the emission and effect of electron and the operation of electronic devices, logic gates, AND gate, OR gate, these circuits. Electron refers to the science of electrons' emission and their behavior in semiconductor. How different semiconductors respond to the flow of electron. That is studied in the branch of physics which is given the name of electronics. Electronics is the study of electronic circuits and their application. Electronics is the study of electronic circuits and their applications. Now, next, thermionic emission. So basically, from this we conclude that electronics, in basically we studied electronic circuits and their application in daily life. For example, logic gates are used as for security purposes, for opening the doors automatically, and the gates are used in computer for counting purposes. Gates are used, logic gates. So different application. The branch of physics in which we study this, the flow of current and the electric circuit in which the current is flowing, the path of flow of current is called electronics. Now, thermionic emission. Thermionic is the emission of electron from metallic surface due to absorption of heat. So emission of electron, emission of electron due to absorption of heat. Due to absorption of heat is called thermionic emission. When a metal is heated sufficiently, its free electrons gain enough kinetic energy to leave the metal. This process is called thermionic emissions. Here you are heating, this is the metallic surface. Different atom and electrons are shown in the diagram, in this diagram. Here it is heated. So free electron are the emission of free electrons starts. Emission of free electrons starts. So due to when you heat it, this metal surface, emission of electron will take place. This process is called thermionic emission. Now, thermionic emissions. What would happen to the electrons if an anode positive electrode is placed near the cathode? The emitted electrons are attracted by the anode. Anode will attract the emitted electrons. For example, this is electric heater. It heats the metal and emission of electron will start. Emission of electron will start. So when emission of electron starts, will be attracted towards the positive terminal of the battery, which is called anode. This is vacuum between the anode and cathode. And when metal is heated, emission of electron take place and will be attracted towards the positive terminal of the battery. The anode exerts a force on each electron, on each electron. The anode exerts a force on each electron. The electron gains kinetic energy. Anode will attract the electron. Now, thermionic emission. If an element, tungsten is an element used in bulb as a filament. When it is heated to about 2000 degrees Celsius, some of the electrons have sufficient kinetic energy to escape from the surface of the wire. This effect is called thermionic emission. When the filament of the bulb is heated or gain heat to 2000 degrees Celsius, emission of electron will take place. The emission of electron always take place at a particular temperature. This effect is called thermionic emission. It is quite easy to imagine this if we think about a metal wire as a lattice of ions in a sea of free electrons. In effect, we are boiling the electrons off. Now, factors affecting rate of thermionic emissions. Here the filament is heated. It heats the metal surface. The kinetic energy of these electrons increases. Kinetic energy increases. Kinetic energy increases. When kinetic energy increases, velocity increases. Velocity increases. As we know that kinetic energy is equal to half mv square. Temperature of the surface. More will be the temperature, more will be the emission of electron, more will be the process of thermionic emission. So temperature is directly proportional to the process of thermionic emission. Nature of the metal surface. It also depends on the nature of the metal. In some metals, the emission of electron will take place easily because some metal have more number of electrons. So the electrons in the last shell, if this is nucleus, this is first shell, second shell, third shell, fourth shell, the distance from the nucleus increases. When the distance increases in the last shell, the force on the electron become weaker, so they are loosely bounded, so a less amount of energy is sufficient to eject the electron from the metal surface. Surface area of the metal, it is also directly proportional to the surface area. More will be the surface area, more will be the emission of electron. Now we will explain analog quantities and digital quantities. In the next coming lecture we will study further detail of analog circuits and digital circuits. We only describe analog and digital quantities. Now analog quantities. An analog quantity is one that changes continuously, or remains constant, or remains constant over a long period of time. For example, changes continuously. The temperature of the day, the temperature during a day or during a 24-hour changes continuously, rises smoothly. Temperature rises smoothly or continuously from 14 to 15 degrees Celsius, not by leaps, jumps. There are countless possible temperatures between this and 14 degrees Celsius and 15. So day temperature changes continuously, decreases, increases. This process is continuous. So this is an analog quantity. If you take density of water, it remains constant, 1000 kilogram per meter cube. Density remains constant, so it is analog quantities. Pressure is analog quantities. time is analog quantity. So hardly you will find an example of digital quantity. So those quantities which changes continuously or remains constant is called analog quantities. Analog quantities, most physical example are temperature, pressure, light intensity are analog quantities. Transducer are device that convert one of these physical quantities to analog voltage or current. Example, a temperature sensor might produce a voltage in millivolt that is proportional to the temperature in degree Fahrenheit. So, transducer is the sensor, is different types of sensor from which if you convert pressure, atmospheric pressure into electrical pulses, then you will do it with the help of sensor, pressure sensor, temperature sensor. Now this is the graph of an analog quantities. If you look to this graph, the values changes continuously. So it is a graph for analog quantity. This is analog quantities, values changes continuously. The dots represents values of temperature. Speed, wind speed changes continuously. So it is analog quantity. Pressure, analog quantity. Now this graph represents analog quantity. The red one and the gray one both represents analog quantity. Digital quantity, those quantities whose values vary in non-continuous manner are called digital quantities. For example, 1, 0, yes, no, closed, open, on, off. These are called analog quantities which obey yes, no. There is no values between yes and no. No value between 0 and 1. Digital quantities can be expressed in the form of digits or number. The branch of electronics which deal with the digital quantities is called digital electronics. Digital quantity electronics use only two digits, 0 and 1, and the whole data is provided in binary form, due to which processing of data becomes easy. For example, if you take 22, you will divide it by 2. 2 ones are 2, 2 ones are 2, remainder is 0. I will do again. So now we get 0. After this 11, 2 5s are 10, 1 remainder. 2 2s are 4, 1 remainder. 2 1s are 2, 0 remainder. So 1 0 1 1 0. So 1 0 1 1 0. It is the digital form of 22. This is the graph for digital quantities. This represents 0 value, this represents 1. 0 1 0 1, no other value. Now you look at the given values. I will do for 10. 2 5s are 10, 0 remainder. 2 2s are 4, 1 remainder. 2 1s are 2, 0. So 1010 represents 10. 10 is analog form. This 1010 is the digital form of 10. So to the base 2. So today we studied electronics. In electronics we do what? The branch of physics in which we study flow of current, flow of current, and the electrical circuit in which current is flowing. Electrical circuit in which current is flowing. In which current is flowing. Electronics, electrical circuit means path of current. Path of current. Thermionic emission is the emission of electron due to absorption of heat. Emission of electron due to absorption of heat. When you heat a metal surface, emission of electron will take place. This is called thermionic emission. Emitted electrons are attracted by the anode, and when you heat the metal surface, electron gain kinetic energy, due to which emission of electron take place. Thermionic emission. If you heat the filament of the metal of bulb to 2000 degrees Celsius, emission of electron will take place. This effect is called thermionic emission. It is different for different metals. Factors affecting: temperature will affect the emission of electron, nature of the metal surface will affect, and surface area of the metal surface. Analog quantities are those quantities which remains constant or varies continuously. For example, the day temperature is varies continuously. The day temperature is varies continuously, but the density of a metal, of a liquid, of water remains constant over a long period of time if you didn't make addition to the system. So these quantities are called analog quantities. The temperature is analog quantity, pressure is analog quantity, light intensity is analog quantity, and the transducer are devices which convert one physical quantity to an analog, which convert which produce electrical energy from a physical quantity which is analog. For example, sensor, temperature sensor, pressure sensor, etc. This graph represents analog quantities because the quantity is changing. The value of a physical quantity is varying continuously, changing continuously. This is the graph for temperature. It is analog graph. So temperature is analog quantity. This is the analog. Speed is analog. Pressure is analog. Graph are analog. This is an analog display of graph. The red one and the gray one, both are analog. Digital quantities, those quantities which have only two states: 1, 0, yes, no, closed, open, on, off. This is the graph. This graph represents a digital quantity. 0, this value represents 0, and this value represents 1. 0, 1, 0, 1, 0, 1. Now, difference between analog and digital quantities. Comparison. Analog is signals are difficult. Digital signals possible to analyze. You can easily analyze. Representation is continuous, discontinuous. Accuracy, more accurate, less accurate. infinite memory, easily store, subject to noise, yes, no. Original signal is preserved. Samples of the signals are taken and preserved. Human voice, thermometer, analog phones, etc. Computer, digital phones, digital pens. These are digital quantities. This is not in your syllabus. So only do it for general knowledge, general information. So digital quantities, you have only two states, maximum and minimum. Analog quantities exist in have many values between 0 and 1, take many values. So this is enough for today. Inshallah, in next coming lecture we will go into detail of this. Thank you, students. Wish you best of luck. Allah Hafiz.